Hello, everyone. So today we're going to talk about section 2.6, limits at infinity. Also, we're going to talk about horizontal asymptote. Okay, so we look at infinity limits and vertical asymptote. We have looked at that already, right? And we let x approach number and a result were that the values of y became arbitrarily large, positive, or negative. Now we consider that what happened when x become very large, right? Positive or negative, and see what happened to y, right? So you can see in example 22 here, we're going to investigate the behavior of fx equal to x squared minus 1 over x squared plus 1 as absolute value of x becomes large. So what does that mean? This one, it actually mean like when x go to positive or when x go to negative infinity, right? So when x go to positive, right, the x-axis positive infinity should be in the right hand side. It's just keep going, okay, right? But what happened goes to the graph, right? What's the value of the graph right now? Okay, it's go along with the with the y, sorry, it's go along with the x-axis at, sorry, not x-axis, over here. It's go along with a horizontal line as y equal to 1, right? Okay, so let me write that here. F of x getting close to this line, or you can write as x approach to this line, right? Okay, to this line. Y equal to 1, right? Similarly, from the left hand side over here, when you try to make x become negative infinity, right? You see that the graph also getting close and closer to this line y equal to 1. See that? Okay. So I could say limits of fx equal to 1 when x go to approach to positive infinity will be equal to 1, and limits of fx when x go to negative infinity will be also equal to 1. So in the left hand side over here, you also have a table to check with the value of x and fx. That could show you how the behavior of fx gonna go. So you see that as x go from 0 over here, you got -1, right? And x go to positive or -1, it's both of them going to give you 0. This is like an even function because both negative and positive going to give you of x, both negative and positive of x will also give you the same value of y, right? So positive and negative 2 will give you positive 0.6. Positive and negative 3 will give you 0.8, and keep going when x go to bigger and bigger number, then arbitrarily large, such as negative 1000 or positive 1000, will be 0.9999 something, and it's close to close to 1. See that? So now the definition of a limit at infinity we're gonna talk about. So let f be a function that defined on some interval from a to positive infinity. Okay, so make sure it's defined, right, on the interval from a to infinity. Then the limit of x when x go to infinity will be equal to L. Okay, it means that the values of fx can be made arbitrarily close to L by requiring x to be sufficiently large. Okay, so that's what we just see from the previous example. B, let f be a function defined on some interval from negative infinity to a, then also limits of fx from x to positive infinity will also be equal to L. Means that the value of fx can be made arbitrarily close to L by requiring x to be sufficiently large, negative. Okay, so another definition. The line y equal to L is called horizontal asymptote, or we notate by HA over here, of the curve y equal to Lx. If either limit of Lx when x go to infinity, positive infinity, will be equal to L, or limit of Lx when x go to negative infinity will also equal to L. Okay. So now let's take a look at the graph in the first picture over here. This one, right? You see that when limits of fx, for limit of fx when x go to the positive infinity, let me see, positive infinity, right? It will be equal to, it will be below or and below and goes close to L, right? Then you can still also call horizontal asymptote at y equal to L. Even though you see that there is a crossing horizontal asymptote, but we still allow if the graph cross the horizontal asymptote, but for the vertical asymptote, you will not allow to have that. Okay, only for the horizontal asymptote. If there's like crossing point between graph and the horizontal, that's fine. But and like finally, if you see the graph at the when x try to approach to the negative infinity or positive infinity and make the limit become L, become that the value of the horizontal asymptote, then you can still call it is a horizontal asymptote. Okay. The second one is clearly told you that y equal to L gonna be the horizontal asymptote, because when x go to positive infinity, um, you can see it is go along to y equal to L, right? So you see above this case, the graph is above y equal to L. And the last one is is crossing, right? See that? It's crossing. It's crossing. The graph crossing the y equal to L. It keep crossing, right? And 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 it's still go along when x go to positive infinity. It's keep going along with y equal to L, right? So we're still gonna say, oh, this is horizontal asymptote for for the graph. So we note that crossing horizontal asymptote is allowed. This statement is not true for vertical asymptote. Okay, make sure that for the vertical asymptote there is no crossing. Okay. Example 23 here. We're going to answer the question, how many horizontal asymptotes are in the graph of y equal to 10 inverse tangent of x below, right? So you can see when x go to the positive infinity, the line, the function will go along with the line y equals to pi over 2 over here, right? Y equal to pi over 2 over here. So you can say limits of fx when x go to positive infinity will be equal to pi over 2. Okay. So far so good. For the x go to the negative infinity, you can see that the line, the graph go along with the lines negative y equal to negative pi over 2. So we say limits of fx when x go to negative infinity will be equal to negative pi over 2. So from the definition of the horizontal asymptote, we're going to say there's two horizontal asymptotes, which is y equal to pi over 2. Oops. Pi over 2. And y equal to negative pi over 2. So remember that there are two horizontal asymptotes, y equal to pi over 2 and y equal to negative pi over 2. Okay, so make sure you check uh, check the limits. So check limit as x go to the positive infinity and x go to negative infinity. Okay. And the note down here is we're gonna note that a function has at most two horizontal asymptotes. You can never have more than that. And for the vertical asymptote, we can have unlimited vertical asymptote. Okay, so let's move up. Find the infinite limits at infinity and asymptote for the following functions shown in the graph. Okay, so easily you uh, let me try to figure out the the limits at infinity first. Infinity, right? If you want to find the limit at infinity, you're gonna find like two answers. One is when x go to the positive infinity, and then the other gonna go to the negative infinity, right? Right. So let's say limits of fx when x go to positive infinity. What happened, right? And the limits of x when x go to negative infinity, right? You can see that for the fx when x go to positive infinity is go along with this line, right? You see that? Okay. And what is this line? The y value equal to 4. Okay. So I can write limit of fx when x go to infinity will be equal to 4. Let me make this one more clear. Okay. Move up for fx when x go to net infinity will be equal to 2. Okay. So far so good. Because let me use the other color. Where's my pen? Hello? Right here. Let me use the green one. Okay. So you can see that the graph when x go to negative infinity will go along with the green line over here, right? And at last, and the line was y equal to 2. Because the value at y there will equal to 2. Okay, let me change the other color. Okay. So from here, you can say that a horizontal asymptote will be y equal to 4 and y equal to 2. Let me circle it. Okay, now what about the question like, does the function go up to positive or negative, right? So, or we actually gonna find, try to find vertical asymptote. Right. Okay. So, in order to find the vertical asymptote, like when fx goes to negative or positive infinity, right? So you can see that when fx goes to positive infinity, over here, positive infinity, right? See that? And when it's go to also over here, this one, infinity, right? When what else? Over here, see that? And when it's go to the next infinity, this guy, let's keep going down, right? Let's go to the negative infinity, right? Okay, so now when, right? We're gonna find the vertical asymptote. Okay, so limit Fx. Okay, so here, take a look at the line x equal to let me say -1, right? So when x go to -1 from both ends, you see that, right? Because both inside will let the fx go up to infinity. So I'm gonna say this is gonna go to the positive infinity. For the ones for the other vertical asymptote, you can see as x equals to 2. Okay, so this a little bit different. For limit of fx when x go to 2, but from the left hand side, it will give you a negative infinity, right? Because it's going down, it's going along and going down. It's going along with x equal to 2 and going down. So that's make negative infinity. And for the one from the limits, when x go to fx when x go to 2 from the positive infinity. I mean from the right hand side. That will give you positive infinity and it's going up. Okay. Okay, it's cost a lot of space, right? So let me, how about this? Yep. So I'm gonna make a conclusion. The vertical asymptotes has two vertical asymptotes, which is x equal to -1 and x equal to 2. Okay. So we're done with this problem. Let's try example 25. Right? So y equal to 1 over x and y equal to 0. With the horizontal asymptote over here. Right? You can see that. And y equals 0. That's going to be the horizontal asymptote because the fx go to the positive in when fx goes x when x go to positive infinity, the fx will go along and close to the 0, right? So I'm gonna say limits of limit of 1 of x when x go to positive infinity will be 0. I can, I can rewrite it as like is equal to 1 over a large number. All right, you can try with 1 out of 99999 something. You can see it's equal to 0. Right. What else? Limits of x 1 over x when x goes to the negative infinity over here. Here's positive infinity. Right? It also will be equal to 0. Okay, so limits of 1 of x when x go to negative infinity, you also equal to 1 over negative large number, right? Equal to 0. So I can say y equals 0 is a horizontal asymptote for this case. And you want to find, they don't ask you, but you want to find the vertical asymptote. So that should be x equal to 0 in this case. Okay, from that example, I will have theorem number 4. That's you really need to use this and apply for many limits at x go to infinity later. So this theorem with any r greater than 0 is a rational number. Right? X r can be rational number. Rational number could be could be includes integer plus the fraction things, so that's yep. Except only the one, say, irrational number such as square root things, square root number 2, something like that. It will be irrational number. So okay, so then we have limit of 1 divided by x over r when x go to the positive infinity will be equal to 0, right? So for example, limits of 1 x to power, say, I'm not sure, let's say 3, right? When x go to positive infinity, so it's still gonna give you like 1 over a very large number later on, right? And that's still gonna give you a 0, something like that. And another one down here, we also remember that it's only happened when r is greater than 0, right? And it's also a rational number. So you can apply this, right? When x go to the negative 50, it's also going to give you limits when up 1 over x power r also equals 0. So let's say like limits of 1 out of x power 2, x go to negative 50, and it's also going to be 0. We're sure that the r is never, I mean, in theorem 4, r has to be greater than 0. Okay, so let's move to example 26. Okay, so let's move to example 26. over here, we want to evaluate the limits of 3x squared minus x minus 2, and then over 5x squared plus 4x plus 1 when x go to the infinity. So this could be like positive or negative infinity. Okay. So now the you need to remember that you always, in order to evaluate something like that, you always gonna divide everything by the highest power of x in the denominator. Highest power of x in the denominator. So what is the highest power of x in the denominator? I saw that this is x squared. X squared is highest power of x in the denominator, right? So what I do is I'm gonna have this equal to the limits of 3x squared over x squared minus x over x squared minus 2 over x squared. Everything divided by 5x squared divided by x squared plus 4x divided by x squared plus 1 over x squared. Okay. For x go to positive, go to the infinity, right? Don't forget that. So now let me simplify it first to see what happened. So I have the limits of x go to the infinity, and the first term will be 3 because x squared over x squared will be just 3. Okay. By the way, I want to tell you that from the origin expression, move to the second one, why they are equal each other, because I just divide the numerator and the denominator, both of them multiply, let's gonna say multiply by 1 over x squared, both top and bottom. Okay, so that doesn't change anything. Okay. Now let me come back with this step. So simplify, I have the next one gonna be 1 minus 1 over x, and next one is gonna be 2 over 2 over x squared. Okay. And actually, you know what? I'm gonna apply. I also gonna apply the one of the rule of the limits from the previous session, that I can make it become the limits of fx of the top divided by the limit of the bottom, right? So it doesn't change it at all because it's one of the rule, right? So the bottom now has 5, right? 5x squared over x squared plus 4 over x, and then plus 1 over x squared. Okay. So now I have so I'm gonna say here is limit law, apply limit law with denominator not equal to 0. So okay, so now I have, okay, so you can easily apply, also you can apply limit law for both top and bottom, and you actually can see. Let me change the other color. Red one. Okay, you can easily see if you try to take the limits of 1 over x when x go to infinity, 0, right? From the theorem 4, it's going to go to 0. Also, for the 2 over x squared, it's actually like 2 times with 1 over x squared. That's going to also go to 0, right? Because of the theorem 4. See that? And for 3, it stay there. Bottom, you're going to see that 5 stay, right? You don't want to change anything for 5. But 4 over x going to be limit of 4 times with 1 over x. When x go to positive infinity, that's also give you 0, right? Because the theorem number 4. And so this guy gonna write y equals 0 because the theorem 4. Right? You can check when you can check for some cases like put a very positive number such as 999 instead of x there. You can see that that's 1 over x, that's 2 over x squared, that's 4 over x. We're also going to be 0. So now I'm going to have 3 minus 0 minus 0 over 5 plus 0 plus 0. And then I'm going to have 3 out of 5 at the value of the limit. So far, so good. Okay, let's move down. I have exercise for you to try, number 17. Okay, so let's try. Remember that? The first step is divide everything by the highest power. Okay, don't forget it. All right, and then I have exercise 18 and 19 and 20 for you to try. Okay, so I can give you the answer key for all of them to make sure you guys later on can get it. Other than that, we can later on. So answer in here is answer for the exercise 17 will be -1/2. Okay, for the next one, I'm gonna say it's gonna be -infinity. Okay. The next one, 0. And 20 will be 0. So okay. There is some rule that you should keep in mind, that numerical has degree, right? Degree larger than denominator. What's the degree? Okay, I want to remind you guys that degree is the highest power. Okay, degree a polynomial will be equal to the highest power of x, right? So for example, in here, this column number 19, or I mean, let's move to 19 first. Okay, so degree for the top equal to the highest power at the top. What is that equal to? 3, right? And degree at the bottom equal to 4. highest power is 4. See that? What else? Let's move to the example that we did. 16 over here, right? Degree at the top. Degree of the top equal to 2, right? Over here. Degree bottom equal to 2 also. See that? Okay. So just keep in mind that. Now let me move down to the notes over here, right? If the numerator has degree larger than the denominator, okay, there's a rule that you can keep in mind that limits of x squared from x for x go to infinity will give you the value as positive infinity or negative infinity. Either way, I mean, it could be positive or negative, right? For the numerator has degree equal to denominator, it's right away going to give you the ratio of leading coefficient. Okay, so maybe you guys are gonna say, oh, what is the leading coefficient, right? Let's move up to the example that we have finished over here, right? Too far. All right. Leading coefficient for the top. Leading coefficient for the top. Okay, leading coefficient is the constant that's next to the highest power of x. Constant highest power of x is 3, right? So I put 3. Leading coefficient of the bottom equal to the constant next to the highest power of x, which is 5, right? And that's the reason why you have the value of the limits here will be equal to 3 alpha. See that? So ratio, right? Ratio of leading coefficient. So we just put 3 alpha, right? Using the leading coefficient of the top divided by bottom, and it's that. Okay, so last one, numerator has degree smaller than denominator, then you're gonna have limits equal 0. Okay, so let's move to the examples 27 over here. We're gonna find the horizontal and vertical asymptote of fx equal to square root of 2x squared plus 1 divided by 3x minus 5. Okay, so now you have a square root. And what should you do for this case? Okay, so vertical asymptote, we need to find where does the bottom of the denominator equal to 0. We need to find when it becomes 0, right? So you can just say 3x minus 5 equals 0, right? You don't have to calculation. You don't have to have any calculation for this. Just gonna be very easy by plus and minus 5. I mean plus 5 and divide by 3. Then you're gonna have x equal to 5 of 3. That's going to be vertical asymptotes. Okay. For the horizontal asymptote, we need to find the limit, right? For the vertical asymptote, we don't have to worry about the limit, but we just put the bottom equals 0 and solve x. Okay, for the horizontal asymptote, we're going to find the limits of fx when x goes to infinity. So in this case, first thing, you're going to find the highest power of x at the bottom. What is that? It is x, right? So, so we will have multiply by 1 of x for both top and bottom. I need to, I forget the limits, right? I write the limits. When x most of us usually when I forgot the forgot to find the limit before I go to the next one, right? So you're gonna multiply that by 1 of x. No, let me write it first. Let me write this one first. 2x squared plus 1, right? And then this one is 3x minus 5, right? Let me have a parenthesis here. So what you do is you're going to multiply it by 1 of x for both top and bottom. Okay, because you have the highest power of bottom going to be x, so you multiply by 1 over x, or divide by x, the same thing. So now it's going to be equal to, if you limits when x go to plus infinity, right? If you try to put 1 of x into the radical, right, you need to make sure 1 of x will be changed to be the same radical. So which is 1 of square root of x squared, right? I can rewrite it like that. And bottom will be easily rewrite as 3 minus 5 over x, right? You can see here. And the top, for the top, the radical is still gonna be 2x squared plus 1. Okay, now time to put the 1 of square root x squared into the radical. Now we have limits equal to limit of x for x go to positive infinity of square root of 2x squared divided by x squared plus 1 out of x squared divided by 3 minus 5 out of x equal to the limit of x for x go to infinity. Okay, now even though, okay, wait, let me simplify for the top first. Later on, you guys can skip some step, but for now, I want to make it everything clear, right? So that's the radical now have radical as 2 plus 1 out of x squared. Everything divided by 3 minus 5 over x. Okay. So now you can have easily as square root of 2 plus 0 because the 1 over x squared when limits for the limits when x equals to infinity, it's going to be equal to 0 divided by 3 minus 0. So then it will be equal to square root 2 divided by 3. And you're going to have y equal to square root 2 divided by 3. Or actually, I would say like limits of fx when x go to infinity should be square root 2 over 3. That's going to be the horizontal asymptote. Okay, so I should also write y equal to square root 2 over 3. That's going to be the horizontal asymptote. Okay. That is the first one. What about case when x go to the negative in t and see what happened, right? Usually for the horizontal, you have to check when x go to positive and then when x go to negative, and let's see, right? If it have the same, then it have only one horizontal slope. But if it have like different, then you have different horizontal asymptote. Similarly, you will have for it, you're gonna have limits of x. Oops, what happened with the pen? When x go to negative infinity. Okay, but now the top. Actually, let me have square root 2x squared plus 1 first, and the bottom will be 1 of x 3x minus 5. Let me write 3x minus 5 first. 3x minus 5. Then you also have to multiply it by 1 of x, right? But now, watch out for this step, because you try to make it get into the radical, right? So you wanna change this 1 of x become let me rewrite this. So limits x go to negative 50. Now the top gonna be square root of 2x squared plus 1, right? And multiply by. Okay, so watch out on this step. You actually gonna have a negative of 1 of square root x squared. Why? Why you have a negative instead of a positive? You should understand that in the case that for this one, x because so let me note, because x is negative, so we have when we change from 1 of x to be 1 of square root x squared, it's going to be a negative. Okay, so 1 of x will be negative 1 of square root x squared. Right? Okay. So now I have Now I have bottom has still have 3x minus 5, right? And you can easily have answer S. Okay, so now I can actually skip some step, but let me make it over here. Limit x go to negative infinity. Okay. For the top will be square root of 2x squared divided by negative x squared, right? So gonna be negative 2. Square root of negative 2, right? And what else? And oh, actually, you know what? I'm gonna left the negative outside, so we don't mess up with that. Square root negative. We're gonna put the negative one outside and let the square root of x squared inside, right? So 2 and then plus with 3 out x squared. No, sorry, 1 out x squared. And the top gonna be 3 minus 0. Now, so not I haven't finished the limit, so I'm just gonna keep it at 5x first. And now I will have top as negative 2, negative square root of 2 plus 0 divided by 3 minus 0. And that's going to give you negative of square root 2 divided by 3. So then the other horizontal will be y equal to negative square root 2 over 3. Okay. And take a look at the graph over here. You can see that when x go to the negative infinity, is the graph go along with the line y equals to square root negative 2 over 3. And when x go along, when x go to the positive infinity, right? You're gonna see that the graph go along with the line y equals to square root 2 over 3. So, yep. So then these are the horizontal asymptote. Okay. Down here, we also have some exercise for you to try. So let's say let me give you the answer key. So vertical asymptote first, right? Will be x equal to 2, negative 2, right? Easily. Okay. For the horizontal asymptote, okay, let me see if I have enough space. Okay, horizontal asymptote. It is have two horizontal asymptote, which is 3 and y equal to negative 3. Okay, you can try. Go ahead. And the fact that you also should know is limits of e to the power x when I go to the negative infinity will be equal to 0. Let me see. Okay, yes, and limits when x go to infinity for e to the power negative x will also equal to 0. Okay, so you can try to check this on the decimals. Let's go ahead and go to decimals. All right, so here is a graph of e to the negative x. You can see that for x goes to the positive infinity, the fx go along with the x axis, which is which is y equal to 0, right? And for the case that for the graph of e to the x, you can see that if x goes to the negative infinity, then the graph is go along with the x-axis also. So again, that's also going to be equal to 0. So yeah, that is. Let me go back to the where it is. Over here. Okay. So now example 28. Let's try to compute limits of 2 minus e to the x and 2 plus 9 times e to the x. Okay, so we what we do is we're gonna divide everything by remember that. Oh, let me use it. Let me use the other color once again. Okay. We're gonna divide by e to the x for both top and bottom. Okay. So what I have here? I'm gonna have limit x go to the positive for the top gonna be 2 minus 2 to power 2 over we have more space, 2 over e to the x minus e to the x over e to the x, right? And then next one is 2 over e to the x. Let me change this like this so we can e to the x. And then plus with 9, oh my, 9 e to the x divided by e to the x. Okay, so top will be, limit will be x go to the positive infinity, and now you have the first term will give you let's simplify as 2 over e to the x minus 1. Everything divided by 2 over e to the x plus with 9, right? So remember that we are working on x power positive infinity. Let me confirm this. So why I have to divide by this, right? Because we are hooking on x equal to positive infinity, so we should try to use this. But in this f of x, you don't see any e to the negative x at all, right? So that's the reason why you need to divide by e to the x. Okay, so you have you now easily see that there is e to the negative x for the first term, which is I can rewrite it as for the first term gonna be 2 times e to the negative x minus 1. See that? Because e to the negative x actually like 1 over ex. So, and then 2 times e to the negative x also, and then plus with a 9. So then now you have negative 1 over 9 as the answer. Okay, so you can try to do the exercise 22. And the answer should be negative 2 over 7. Okay. So I'm gonna stop this section here. And we're done with this way. Hope you guys try to finish the notes and the group work as soon as possible. Also the website. See you guys next time. Okay.